All right. So let's look at these two highlighted examples up top. Uh, we'll look at this one and this one. We're not gonna look at every single one of them. We'll look at a couple of them though. Let's look at definitely A. Uh, let's see. Let's look at B and F up top. All right. So for A, what's the first thing we need to do?
Can you record this one?
It's recording.
Okay, my bad.
Yeah. I haven't the class from Friday. I just haven't had a chance to chop it up yet. But I'll do that today and I'll upload this today as well. Yeah, but it is recording though.
Cool.
Mhm. All right. What's the first thing I need to do for A?
Change the diene to SS confirmation.
Make the diene SS. Good. So I'm just gonna take this little empty space over here and we're gonna work it. So this is my diene. And then my diene file looks like this. I'm just gonna get rid of the ring because the ring will confuse you. Just for as a rule of thumb, that benzene ring that's shown here, it'll never participate. We're going to talk about aromaticity a little bit later, but that'll never participate in a cycloaddition. The double bonds are too stable and they're not really reactive. The only way you get a benzene ring to react is with a catalyst. So anytime you see that, you can just kind of rule that out. So we know that this is going to be the dienophile, and then this is the diene. All right. So over here, this is my benzene ring. I can abbreviate that as pH, right, for phenyl. All right. So what does the product look like? Right. We can actually, let me turn this around to make this easier. Let's do it that way. What's the product going to look like?
The right side of the benzene is going to connect to the right side of the.
Say that again now. Is it going to be on the product is going to be a 6-member ring? Is that right?
Yeah.
Because this is the mechanism. It never changes. Is that right?
Yes.
So my double bond is going to be here. And if we number this, 1, 2, 3, 4, 5, and 6, right? So for the, let me move this over some. So this is the backbone. The double bond is here. This is 1, 2, 3, 4, 5, and 6. So what's on carbon 6?
The benzene ring.
The benzene ring. Right? So that's the product for A. That's what the product is going to look like. That benzene ring will not participate. I don't care how much you heat that reaction up. That's not going to be those double bonds won't participate. All right. All right. Let's look at what did I say? Oh, I got the circle. B. Let's look at B. Any questions about A before we move on to B?
No.
All right. Let's do B. Right. You can see the diene right here. And then you can see the dienophile right here. What are you taking into account with the dienophile for this example?
The branches attached to it.
Right. What about them?
They're gonna stay there you just need to account for them on the ring.
Okay.
Keep the stereochemistry.
Yeah. So you're looking at the double bond, and we're saying that double bond is what? It's trans or cis?
Cis.
Trans. It's trans, right? The groups are opposite to one another. Can you see that? That the chlorine is on the opposite side of. Let me get all this other stuff out of here. The chlorine is on the opposite side of the ester, so it's trans. So you're right that the branches have to stay there, but then I heard somebody else say that they have to be trans also because the reaction is stereospecific. Is that right?
Yes.
Yeah. So I'm gonna just go ahead and put the arrows in here. Like so. Right. So the product from that particular reaction, I'm gonna draw it over here. It's gonna be obviously it's gonna be a 6-member ring. And then my methyl groups don't move. But over here,
One's gonna be wedged and the other's gonna be dotted.
yes. And then I need to move this over a little bit more. All right, so one of the so you got one of these is trans and one of these is cis. I'm sorry. One is wedged and one is dashed. Let me get this out of the way too. My dash looks kind of sucky. Let me fix that. All right, so one, and it doesn't matter which one, right? Either one of those could be wedged or dashed, as long as you show that it's trans, right? And again, it has to be trans because the reaction is stereospecific, right? All right. Any questions about that example?
No.
All right. Let's do F. Uh, can I erase this, or are you still writing?
I can.
All right. All right. Let's do F. F is it's not a tricky question, but it's a question where you got to think about what you're doing. Right. So let's first identify the diene, which is here. Is that right?
Yeah.
So that's my diene. And then where's my dienophile? Is it here?
Yes.
Yeah. Oh, thank you, whoever circled that. I appreciate it. That's my dienophile, right? But notice there's something about this problem that's a little bit different, right? It says that your diene is in excess, right? So let's just say excess in this case, let's just say that this is 2.0 moles and this is 1 mole. All right. So what does that mean?
Can the reaction happen twice?
It can. That's exactly right. Because you also have another double bond on this side, right? And so if the diene is in excess and you have multiple dienophiles, then that reaction is going to happen twice. So let's see what will happen here. Let me just draw this. I'm going to turn it around like that. Right, so that's going to attack there, here, and here. And then the same thing can happen on this side, right? You're going to attack here, here, and then here. So what would the product look like? Can somebody draw it, if you don't mind? You can draw it down here in this empty space. Is that a no? Okay, I'll say it's worse than being in class now when y'all won't get up and come to the board. We can't even see you. Okay. Okay. I feel like I'm watching a time lapse photo video.
I don't know what to do now. I got lost.
You did okay. Let me see if I can match you. Uh-oh.
Shouldn't there be 3 benzene rings attached to each other, and double bonds on the outside, and then in the middle benzene will have the oxygen?
Yeah, you have 3 cyclohexene rings.
Yes.
Yeah. So you're in the right wheelhouse. This part is right. The middle part will look like this. Was that right?
Mm-hmm.
All right. And then you also have to take into account the other side, right? So you're gonna have the same thing on the other side.